Okay, everyone, let's get started. Good morning. My name is Miriam. I will be moderating this session. Bryn is going to talk about CQL with implementation guides and versioning. After his talk, we'll have some time for Q&A as well. So please wait with your questions until then, and I'll walk around. So thank you, Bryn. Go ahead.
Thank you so much. Standard strategy at Smile Digital Health. I'm also a co-chair of the CDS working group. I'm on FHIR management group and the terminology services management group. So CQL model info. Let's just dive straight in. So CQL as a language doesn't care what data you're running against, but because of that, it needs the definition of what data you're running against. So whenever you're writing a CQL library, you need to provide the model information for what you're writing against. Most of the things that we see within FHIR space, we just say using FHIR version 4.0.1. And that means there's a model info file named FHIR that actually describes all of the classes that are available. So here's an example. This is the class info for the patient resource. It's got the identifier there. That's actually the URL. And then for each element, just all the elements that you see in the patient resource are exposed as elements in this class info. So model info is just a very simple description of basically object-oriented classes. Those model info libraries or files are then packaged as library resources in the same way that you can package a CQL library, you can package a model info. That then is looked up by URL, just like any other canonical resource, which means then we can start sharing them in implementation guides. As we'll see in just a bit, it just drives off the structure definitions, so you can actually have model infos for each implementation guide. So as you publish an implementation guide that has profile definitions in it, you can have a model info that captures and characterizes those profiles. For example, QI Core and US Core now include model info directly. Those are ideally, they're published with the specification. But if you have an IG that doesn't have it, you can also generate it alongside and use it with it. So a little more detail on that. Basically, for each structure definition, a class info with that same name is created. If it's a primitive type, a complex type, except extensions, we'll talk about those in a bit, or resource, and it's a specialization. For each element, if it's not a backbone, then you just get a corresponding element created in the class info. If the max cardinality is 1, it's created as just that type. So a string or a quantity. If its cardinality is greater than 1, then it's created as a list of that type. And then if the element is a backbone, so you're looking at something like patient.contact that has structure directly in the resource, we actually create a new subtype for that and create an element of that new subtype. So you'll see things like patient contact. It's the same approach that's taken to generate class info for things like Java and JavaScript. Same kind of approach. We're just defining the type information so that we can use that within CQL. If you want to actually use the tooling that we use to generate this, I've got a link there. It's kind of hard to read, but I wanted it all in one line, and they're in the slides, so you can just go click on it. But that takes you right to the model info structure definition to model info description in the CQF tooling. And you can run that. There's a command line example. This is running the QI Core 7 model info using that CQF tooling. And what that'll do, in addition to the defaults that it just looks up out of the structure definition, we can actually put extensions onto structure definitions to kind of guide this process. So we can say whether or not it's included. Let's say we have a profile that we don't want to come out at all. We can just say exclude that. Whether it's retrievable, so whether or not you can actually use that class inside a retrieve to actually get data. What human name, so you can actually set the label. If you want it to be, like if your profile is blood pressure and you want a space in there, you can put the label in to specify that. And then the primary code path, so what your terminology path is, that can all be specified with structure definitions. There's also model info settings, so model name and namespace, the patient class name, how it knows, like when you say calculate age, how it knows to go get that information from the patient and the birth date property name. Target qualifier and target URL, that's what how you know, how the provider knows what namespace to look up. And then use CQL primitives, create slice elements, and flatten. Those are different settings that control things like, are you going to, if I have a quantity element, is it going to be a CQL quantity or is it going to be a FHIR quantity, and I have to map that. So there are two main approaches to generating this model info. One is the derived model info, and the other is flattened. So we'll talk about derived first. Basically going through a derived model info, you set the namespace name to the model name, like US Core. Let's say we're walking through all the US Core profiles, and for each of them, we define a class info. The name is set to structure definition name, so patient profile in this case. Without the prefix, if it's the same as the model, so we don't have US Core patient profile. And then base type is set to the base definition of the structure definition. So US Core patient is based on FHIR patient. And so we actually, in derived model info, set up that same relationship. And then the identifier is set to the URL. The label is the structure definition title. So by default, that gets set. Retrievable is true unless we override that with that isRetrievable extension. And then the primary code path we set based on an extension. Flattened model info is where we drive off of the snapshot in the structure definition instead of the differential. And then we do that to create a simplified view. So instead of that hierarchy where a FHIR patient and then a US Core patient and then a QA Core patient, we actually flatten all of that into the same level and present that as a single kind of unified view to the authors. We've been doing that for a while, and it also gives us a way to create extensions and slices and surface those as first-class elements. So, for example, the ethnicity and race extensions in US Core are exposed directly as first-class elements. And that's a really nice kind of authoring experience. But it has some drawbacks. One is that it limits reuse of functions. So with that flattening approach, different models have different classes. They're completely separate types. Like patient in US Core is a different type than patient in QI Core. So then we can't write functions that work across those. If I'm only looking at one model, then it's fine, and it works really well. But as soon as I try to bring other implementation guides in, then I'm faced with some challenges. Other different models appear to have different base types. So FHIR.reference, USCore.reference, QICore.reference. Those are all really the same type, but because we flattened everything, they show up as different types. It also doesn't lend itself well to cases where types aren't reprofiled. So US Core 3, for example, didn't include service requests, so there's just no way to talk about service request at all. And then there's also lots of duplicative content. So you end up with very large model infos. So let's look at function reuse in the derived versus flattened case. So in flattened, if you're looking at QI Core common right now, You have to do this condition as a choice of condition encounter diagnosis and condition problems health concerns. You can't actually talk about a condition in the generic because US Core introduced 2 different profiles. And so if you flatten, then you have to talk about each one independently. As opposed to a derived function where you could just talk about the FHIR condition and it will work with US Core conditions, whatever profile, QI Core conditions, whatever profile. As a slightly more dramatic example there, is resulted, there's all these different observations that you have to account for if you're dealing with a flattened model. And each of these is effectively its own class. We have 5 minutes left. Perfect. And then derived, we get one is resulted function, and we can deal with all the observations in the same way. So there are clear advantages to doing this using this derived approach. And because of that, right now, US Core 6, QI Core 6, FHIR 4, all of the assets that we currently use use flattened model info. So there's a CQ framework draft with US Core Common. The measure authoring environment has its own QI Core Common, and CQ framework components includes the actual QI Core model info. So we distribute that as part of the translator. Going forward, to make this more distributed and support implementation guide usage, we're going with the derived approach. So as of US Core 7 and QI Core 7, the Using CQL with FHIR publication, we talked about that a little yesterday, will include the FHIR helpers, FHIR Common, FHIR model info. The US Common Assets, which is just went through ballot, we're about to publish, will include US Core Common that derives from FHIR Common, and a US Core model info that derives from FHIR model info. And then the QI Core publication will derive from that US Core model info. So going forward, we'll be able to use any implementation guide by just bringing it in. So then the new FHIR Common, we removed all the functions that were deprecated, that were marked deprecated in the previous version. Those are all gone now. We added interval functions from QI Core, so has start, has end, some of those utility functions. Renamed extensions to ext and exts. We removed the base extension functions. No, those weren't being used, so those are just gone. And then we added helper functions across observation, condition, allergy intolerance, medication request, and encounter. And these are ones that we've been using in measures and decision support and population expressions for prior authorization questionnaires. So then that means the new US Core and QI Core Common, most of the content that was in there was refactored and either disappeared because it was duplicate, or it moved up into FHIR Common. And then US Core Common now only has US Core specific content. So there's only a handful of functions in US Core Common, and QI Core Common now only has QI Core specific extension functions. And then the goal there is to present a uniform API for consumers. So now as we look at 7.0, US Core 7.0, we're able to provide a view that then is backwards compatible with 6.10 and 7.10 and 3.11. So as you write your logic, you deal with it as US Core 7, and then consumers don't have to worry about those differences. Those are made up for within the logic. There's a little more detail on that, but this is the approach that Da Vinci guides like CRD and DTR have all been taking. So there are version-specific wrapper packages for each US Core version. So instead of just depending on one version of US Core, CRD actually depends on all 3 versions. And from the CQL space, now we can say we're using CQL 7, and that brings in the prior versions as well, because the profiles are effectively backwards compatible, and if you have a 7.0, then you're able to, like a 6.10 instance is conformant, and a 3.11 instance is conformant for most things. But because we have the ability to bring in model info from multiple implementation guides, we can bring those in and work that way. So we have some, there's a couple slides. I'm out of time. I'm out of time, but basically, because we're using derived, then we get to basically attach that in the same way downstream. So US Core, we have these kind of rolling 3-version windows where we deprecate the old one and we bring in support for the new one. And then QI Core, as a derived version, just works on that same balance. And then, ideally, this also extends to the FHIR itself. And so the rolling window from DSU2 to R4, and then DSU2 rolls off and R5 rolls in, and so on. So that's the part that we're working on next, is to make sure that we can support that in CQL as well. And you can reach me here. Questions?
I think. Hello? Is it on?
Yes.
Yeah. Hi. I had a question yesterday for someone that said they wanted to use CQL with FHIR 5. Mm-hmm. So then we would obviously need a FHIR 5 model info, and FHIR helpers probably included with FHIR 5. Is that already available?
It's not available yet. It is on the list, though, to build that out, and it should be within. Anya submitted a tracker on that, so we'll get that within the next couple weeks. I don't know where we're going to publish it, but we'll make them available.
Okay.
Because we don't actually have an R5 implementation guide we could plug them into yet.
All right.
So.
Just one more question.
Yep.
This is more related to an engine. If you have like multiple libraries, if you have usings with different FHIR versions, that should never be allowed, right? That cannot happen.
So right now it cannot happen, but I'm actually making changes to make it possible for that to happen. The reason is, one, we want to be able to support this multiple versions going back. Right now, to do that, you actually have to say using US Core 3 and generate a model info that is for that version. Yeah. Right. We want to be able to say using US Core 3.1.1 and using US Core 6.1.0 and 7.0 all in the same, because I want to be able to write logic that converts between them, so that I don't have to expose that downstream.
Anyone else?
So when it comes to model info and making it a useful tool for implementers, do you have thoughts on making tooling, whether it is for actually integrating into code editors or UIs that make it easier for somebody who's writing CQL to actually understand what model info functions and tools and fields that they have access to?
Yes, 100%. So this is the VS Code plugin, for example. One of the things that we're adding here is it can use the model info to give you. Well, I was. Let's just close that and see what happens. Oh, it's a totally different thing. So you'd be able to say things, when you hit a dot, for example, FHIR helpers dot, to date, patient dot, that model info should be able to be used there to bring up a list. Right now, it doesn't do anything. We don't have that plugged in, but that's the kind of thing that model info can support. And we've added a bunch of decoration in model info, so that all the information from the structure definition, like the comments and the requirements and bindings. All that comes through in the model info as well. So you can use that to provide those types of like IntelliSense and look ahead in an IDE. Yeah.
Okay, thank you. That was all we had time for. So thank you very much, Bryn.
Thank you.